Okay, so we are getting into 1.5 here, and that is displaying quantitative data with histograms. So we did stem plots last section, and now we're going to get into histograms and describe what those are and be able to analyze histograms and create histograms. So um, first of all, what's the difference between the dot plot and the histogram? As you can see, it shows each interval as a bar. The heights of bars show frequencies or relative frequencies if you're dealing with percentages. Um, and as you're looking at this, you have to understand we use this when we have way more data. We don't want to have to create a whole bunch of dots as we are putting the data here. Okay, so again, if you look at this and you can see the individual count on this dot graph that we did earlier, but you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 is the count of these first three dots here. And as you can see, we split this at 1.75, and that's where this would be as well, 1.75. So the count, they tell you the relative frequency, and this is right here, goes to about 18. Okay, so it includes the same amount of numbers. You just can't see the individual count, and it groups them into a little bit larger of a space where this is everything between 1.5 and 1.75. You can clearly see at 1.5 that there are two. At 1.6, there's 1, 2, 3, 4, 5, 6, 6, so forth in the dot. But here it kind of shows um, as they get larger, just they're spaced out a little more and you don't have the individual count. Okay. It's used for larger sets of data, like I said, and grouping nearby values creates a cleaner picture of distribution. It just kind of makes it a little bit neater as we go through this. And again, same thing with the stem plate. Five intervals is usually a good minimum. When we create these, we're going to use the applet, um, the stats app that we used before. We'll just go into the quantitative data as opposed to the categorical data. But we're going to do an example like that next. And here's a very important thing. We include the left-hand value in the interval. So this right here, if it were on 1.75, would actually be included in this tall box right here, okay, or tall bar here. Anything that is included, it's included on the left-hand bar. It's included there. So we need to look at that. Okay, and just something to keep in mind. Include the left-hand value in the interval, so it's included right here. Okay, let's take a look at this example. So you're going to see that there's a lot of data as we're going through this, and you may need to take pictures as you're looking at these to enter this stuff. So this says, how does the percent of foreign-born residents in your state compare to the rest of the country? The table presents the data for all 50 states in 2011, and we want to make a frequency histogram to display the data. So as we go to display the data here, we're going to go to the apps. And again, I would highly recommend when you have something like this, you take a picture, or if it's we're not using a book, so take a picture with your phone so you have all of the numbers available to you. And when we go to make this frequency histogram, again, we want to be in one quantitative variable. We want to make sure that we label this correctly. So again, if we look at the name of this is how does the percent of foreign-born residents in your state compare, or per state? So this would be the number of foreign-born residents per state. So we're going to type that in there, number of foreign, should I spell this right? That's all right. I'm a math teacher, right? There we go. Foreign-born residents per state. Okay, roll data, and now we have to enter all of this data. So this is going to take a second. And we just separate with a comma. I don't need to let you know every single number as I enter these because you have it right in front of you. it's time consuming. It's tedious. That's why we don't do 20 problems. I give you 2 or 3 to do. Where'd you go? There we go, 9.6. I was at 18.2. And as you're doing this, this is the one thing that with stats that kind of gets tedious, but you have to make sure that you don't have human error. You have to make sure that you enter the exact number that is given, or else your data will be off just a little bit from what is expected of the correct answer. So as I'm doing this, you can obviously fast forward the video, um, or you can enter this in and do the problem with me. But this is part of the time-consuming issue of this. And again, make sure you don't have any human error, which I may very well do. I'm going to show you how to check that you don't have any human error when you are finished entering all these datas. Point 3, almost finished here. 4.8 and 2.9. Okay, so we can begin analysis. We want a histogram. Okay, so as you can see here, okay, and as we do this, my N right here, this is how it tells you whether or not you entered this right. As long as you press all the buttons right, sometimes my fat fingers hit the wrong thing. So you just want to double check it as you're entering it. But you know that I entered 50. There's 50 states. I have 50 total numbers here. So again, I had to change this from dot plot. When I went to dot plot, I had to change that because we're working with histograms. So here is the histogram. Okay, and you can see that this is labeled a histogram with frequency. This is not a relative frequency, so we're not looking at percentages. We're just looking at the frequency of it and the interval width, and it automatically went to 5. You can see that if I make the relative frequency of 2.5 and the boundary value, it starts at 0, you'll see that it changes shape here. We just want to look at this one right now for 5, but we can change the shape of that graph. So if I had you make a histogram with a frequency table, you could again copy and paste that. I found that it will not do that with the program that I use. So I've got to do something a little bit different, but you guys can right click it, copy image, and you guys can upload that right to the Edge Elastic. Okay. So again, there's the histogram for that data. Okay. And then if we wanted to interpret that data. Okay, so again, here's how you make it. You would go to the applet and do that. Okay, so the second objective is to so that's how to make it. The second objective here is to interpret the histograms. And we want to make sure that when I talked about this, the choice of intervals is very, very important here when you're looking at this. Here's from 0 to 5, and this would be with 2.5, 0 to 2.5. as we look at that. So the choice of intervals in a histogram can affect the appearance of the distribution, and clearly it does when you change that, and I showed you how to do that in the applet. So now let's go ahead and interpret this data and use the data table from example 1 and the histogram. So here's the data that we're going to use. I know we did it with intervals of 5, but we're going to go ahead and use the one that has intervals of 2.5 to answer these questions. And it says, what percent of states have less than 10% foreign-based residents? So we have to look at this, okay, and look at where is 10%. 10% is down here. This bar right here is 10%. Remember, if it were 10%, it would be included in this bar right here because that is the left value of the bar. Okay, so anything at 10% would actually be included here. So anything less than 10 would be considered here. And if we look at this now, we have the total number of states, what percent? It looks like 5. And then here looks like 10. Here looks like 15. And then this bottom one here looks like 4. So it looks like we have 19, 29, 34 states. Okay, and again, that's 34 out of how many states? There's 50 total states. So we want to multiply that by 100 to get the percent. We would go to Desmos. We would enter in 34, divide that by 50, and then multiply that by 100. And it gives me 68%. So going back to this would be 68%. Okay, so describe the shape of the graph. So when we look at the shape, here's the peak. It's clearly skewed to the right. So we would say shape, it is skewed to the right. Okay. And the peak, and now here, because we're dealing with intervals, we see that this is the peak right here. Get rid of this. So we see that this is the peak, and now we have to put the interval that this is between. So this is 2.5 to 5%. So the peak is 2.5 to 5%. Okay, what are the clusters? And for this one, it kind of looks, this whole thing from here all the way to here in this histogram. So again, that would be 22.5 would be the cluster. So 22.5 to, or 0 to 22.5%. And then the gap, and then you can see that there's one gap right here. That's from 22.5 to 25%. 22.5 to 25%. Then using example 1, which state is the possible outlier? Well, looking at this, you cannot tell what the outlier is, which state it is. It's asking specifically for the state. You can tell that it is between 25 and 27.5%, but we're going to actually have to go back to our data and see which one is between 25 and 27.5%, and that is 27.1, and that would be California at 27.1%. Okay, so 27.1%, and that would be California. Sorry, I'm getting used to this tablet here, writing on my laptop. Okay, so that was objective 2 there. Objective 3 is we're going to compare distributions, and this is really important. There's a couple of things in this section here, and then we're going to look at an example. But when using histograms to compare the distributions, we're going to use relative frequencies, especially, and this is really important, if the groups have different sizes. If the groups have different sizes, then we want to make sure we're looking at the percentages of each distribution, not the actual count. And then we want to use the same intervals so that we can make sure that everything's lined up and we can actually compare the two of those. So again, we're going to use relative frequencies when we're comparing. So we would use a relative histogram. a relative frequency histogram when we did that, and we want to make sure that we're using the same interval. So if we look at this example, okay, and I'm going to just read through this real quick. Why should you get your diploma? It says, is it true that students who graduate from high school earn more money than students who do not graduate? To find out, we took a random sample of 371 total residents, and the education level and total personal income from each person was recorded. Here's the following frequency histograms. So again, frequency meaning we're dealing with the percentage of people of the data. So we had 57 non-graduates and 314 graduates. So that's why we have to use the frequency because of and the percentages, because we don't have an even number here. Okay. And now I'm asking you to compare the two distributions. So what does that mean? We're going to first look at the shape. Okay. So when I ask you to compare two distributions, we're going to look at the shape first. Okay, so if we look at the first one, we can see that the peak is right here and everything else is to the right. So this is, we're just going to call this nose. Okay, the nose is skewed to the right. Okay, there's actually no left-hand data from the peak. It's everything front to the right. And same thing with the yeses. The yeses is also skewed to the right. Okay, the next thing that we're going to look at is the center of each set of data. Okay, we want, again, that's 50%. Where's the 50% mark? If you look at the nose, you see that the 50% mark is right here. Okay, so again, total personal income by 1,000. So this goes by 10, 20, 30, 40. It's going by tens each bar here. So as you can see, the 50% mark is somewhere in here in the first bar, and that would be 0 to 10,000. Okay, so the 0 to 10,000. 0 to 10,000 is the center. And we would say that is less than. Okay, we always want to use, again, more than or less than when comparing two sets of data. The yeses center. And yeses center is, it looks like this one is 30%, right? And then the next bar down is really close to 20%. Okay, so we're going to combine these, and that would be what? Anywhere from 10 to 20,000. So 10 to 20,000 would be the center of the data for the yeses who graduated from high school. And again, if you looked at this and you said, that's not quite 20, and you wanted to include this bar, and you said this was between 20 and 30, that would be okay. Again, it's not exact, but you should know that when I'm asking you for the answer here, you couldn't say something like, the center's at 80, because it's clearly not. It's right in here. I'm going to say that this was 20%, so there's the total 50%. Then we're going to look at variability. Okay, and we're going to look at, again, the variability is looking at the largest to the smallest amount. So we see that from this point right here down to looks like 0. So if we go down, this looks like 60,000. Okay, down to 0. And if we did 60,000 minus 0, that would be, so nose variability, and you could abbreviate that to VAR if you wanted to, is 60,000. And that is going to be clearly, because you can see that this goes way further out to the right, that's going to be less than. So is less than yeses variability. And that variability looks like it goes from 150,000 down to 0. So we would take 150,000 and subtract 0 from that, and that would be, of course, 150,000. Okay. And then we want to look at the outliers. Are there any outliers? Let's make sure we spell that right. Okay, so for the nose, it does not look like there are any outliers, so we would say none. And for the yeses, I would definitely say that the outliers would be out here between 130,000 and 150,000. And if you wanted to, you could also say between 100 and 120. But if you didn't include those, that would be okay as well. Those are the clear outliers. These ones, you could include them, but you might not see them as outliers in this data. So again, when you are looking at comparing the data, you want to look at those four things: the shape, center, variability. And when you say center and variability, you want to use the words less than or greater than as you're comparing that data. So that is 1.5. Have a few problems to do in Edulastic for that.